Good day, general mathletes. Today we are going to have lesson one, of chapter 2. It's entitled Rational Functions, an Introduction. To begin with, let us recite our memory verse found in Acts 26, verse 25. It says, "But Paul said, I am not out of my mind, most excellent Festus, but I am speaking true and rational words." Today, we'll have two learning competencies for our meet-your targets. First, you represent real-life situations using rational functions. And second, we distinguish rational function, rational equation, and rational inequality. Let's take, for example, this expression, 5x over x plus 3. This image asks, am I a rational function? Why or why not? And if I am a rational function, we need to make a twist to make it not a rational expression. And if it's not a rational function, make a twist to make it a rational function. First question we will have in mind, what is a rational function? Now, remember that a rational function is a function in the form of f of x equals p of x over q of x, where p of x and q of x are both polynomials and q of x is not equal to 0. Because if q of x is equal to 0, it makes the function undefined. Now, when can p of x and q of x be polynomials? There are three. First, it must have an integral exponent. It means that the exponent cannot take 1/2, 1/3, and again, the integer must be positive. Second, the variable must not be inside a radical sign. And third, it must be positive. The exponent must be positive. Let's take, for example, this set of functions which are called rational functions. The first one, 1 and x are both polynomials. Thus, this is a rational function. Second, x squared plus 3 is a polynomial. X minus 1 is also a polynomial. Therefore, this is a rational function. Next, x squared plus 7x plus 10. It is a polynomial. It is a quadratic polynomial. And x plus 2 is a linear polynomial. Thus, this is a rational function. Let's take a look at non-examples of rational functions. 1 is a polynomial, but x raised to -2 is not a polynomial. Why? Because the exponent is a negative integer. And the second, 5 plus square root of x is not a polynomial. Why? Because x is found inside a radical sign. Next, x to the 1/3 plus 2x is not a polynomial. Why? Because 1/3 is not a positive integral exponent. Thus, this is not a polynomial. Since these three expressions have non-polynomial parts, then these are not rational functions. Let's go to the second one. Rational function, rational equations, and rational inequalities. These three have numerators and denominators that are polynomials. If it's only a single algebraic expression with polynomial numerator and denominators, we just call it a rational function. For example, f of x equals x squared plus 3 all over x minus 1. But if there's one or more rational expressions making an equation, how do we know it? Through the equal sign, it becomes a rational equation. And if the sign is an inequality, like greater than, less than, greater than or equal to, less than or equal to, or not equal, it becomes a rational inequality. You need to consider this example. Now, let's take these examples. First, this is a polynomial. This is a polynomial, so it's a rational expression. There's an equal sign, so we call it a rational equation. Number two, the variable is found inside the radical sign. So it is not a rational expression. So is none of this, not a rational function, not a rational equation, and not a rational inequality. Number three, it's a rational expression, and it's a single rational expression with the f of x on the other side. Thus, it is called a rational function. Next, number four, this is a polynomial. This is also a polynomial, so it is a rational expression. With the inequality sign, it becomes a rational inequality. The last one, the numerator is a polynomial. The denominator is a polynomial. So this is a rational expression. With the equal sign, it becomes a rational equation. This ends this lecture video for lesson 1. There's still one more problem. Rational functions in real life. For example, an object is to travel a distance of 10 meters. Express velocity as a function v of t of distance per travel time in seconds. Again, the time in seconds is not given, but velocity is a function of distance per travel time in seconds. Remember that our distance is fixed. It is in 10 meters. So all the distances will take the value of 10. 10, 10, 10, and 10. For example, we would need to place a value for time in seconds, or for t. We assume the values to be 1, 2, 3, and 4. Thus, we substitute it to time and velocity. So we say 10 over 1, that is 10. So in 1 second time, the velocity is 10. In 2 seconds travel time, the velocity is 5. In 3 seconds travel time, the velocity is 3.33, and it keeps on repeating. And for a 4-second travel time, the velocity is 2.5. Remember that our distance is fixed. Only the time changes. So how do we express velocity as a function of v of t? That will be 10 over t. Now it's your turn. You do the apply the concepts, MVC boosters, and performance task number 1.